Hello people, almost off grid Dave here. I thought I'd do a little video. I wanted to conduct an experiment on hooking up some solar panels directly to a hot water heater service. Now, I've seen a few videos on YouTube and I thought, well, I've been using a pumped hydronic system for over 10 years, which works very well. And I have got a few surplus solar panels, so I thought I'd hook them up to the hot water service and see how they go. So I'll go through the setup first, and then we'll conduct the experiment. Yeah, so I guess the first thing we should do is to actually calculate the amount of heat required to heat our 50 litre water tank up by say 40 degrees. So here we have a handy online calculator. So the calculator is called kilowatts to heat water calculator. So we want to change this to heating time. So the water amount is going to be 50 litres. The starting temperature, well, let's just say 20 degrees. And the final temperature we want to be about 60 degrees. The heating power, well, I'm going to go for an average of 0.4 kilowatts, and just as an arbitrary value we'll put in 85% efficiency. So if we go to calculate this, that's half a kilowatt. It'll take 6.84 hours to heat 50 litres of water up 40 degrees, or a total power of 2.326 kilowatt hours. So it's sort of doable, I think. You probably get 8 hours of sunlight, but it's going to vary. So if we got a maximum of 800 watts getting into the tank element, it's going to vary during the day. It's going to be less if it's cloudy or overcast. Yeah, but I think it's doable with what we got. So I'm happy with that so far. Okay, so the pumped hydronic system is a system I'm using at the present time. This is installed on my motorhome or tiny home bus conversion. Worked very well for over 10 years. Giving me hot water in the mornings for a good nice shower and stuff like that. So basically consists of a solar collector. That's basically a wooden box with a glass lid on it, and inside is a copper pipe heater matrix. So your cool water or warm water comes out of the bottom of the tank, is pumped around to the solar collector, which is above the tank. Hot water comes out through a check valve and back into the hot side of the tank. The check valve's there for a good reason. At night when the pump is off and obviously the solar's not heating the water, your hot water would actually thermosiphon back up to the solar collector and cool the whole water tank down. Ask me how I know. Okay, so, but I thought I'd do this experiment with the direct PV anyway. So with this, all we're going to do is a very simple bang bang system. Solar panels, 5 solar panels in series to give us a higher voltage, and then we're just going to connect it directly to the thermostat controlled heater element on the water tank. So PV direct electrical system, solar panel and heater element specifications. We'll go through those. So the water heater element is an 1800 watt element. It's rated at 240 volts. If we use Ohm's law, we can calculate the current, which is 7.5 amps, and using Ohm's law once again, we can calculate the resistance of the element, which is 32 ohms. The 190 watt solar panel has a voltage maximum power at 36.5 volts and the maximum power current of 5.2 amps. So with 5 panels in series, our VMP will be 5 times 36.5, which is going to be at 182.5 volts. The current will still be 5.2 amps because they're in series. So as our load is 32 ohms, the maximum voltage across the load is 5.2 amps times 32 ohms, which comes to 166.4 volts. Therefore, the maximum power input to the element is 166.4 volts multiplied by 5.2 amps, which comes to 865.3 watts. So we're going to lose a little bit because we're not running at the maximum voltage the panels can achieve. So this result is for optimum conditions only. Cloud, shade and higher ambient temperatures will reduce the power substantially, but it's a good starting point. So this is the power curve for the solar panel. So you can see that's the maximum point, power point there. So that's the maximum maximum power basically. This is a current. This is the current curve. So as we can see, if we drop this voltage a little bit towards we're still pulling the 5.2 amps. Then we're just going to reduce the power a little bit, maybe down to 170, 175 watts or something. So we will lose a little bit, but that's a trade-off for having a simple bang-bang system, which is what I want. I don't want any black boxes or control systems if I can help it. Right, well let's do it. Let's do the experiment. Right, so here's some solar panels. There's 5 old 190 watt solar panels we're going to use for the hot water experiment. So let's get them over near the house. Okay, so now I have some solar panels up on the roof here. They're just laying on the roof at the moment. They should be okay for a few days. I have got a rail that'll take 5 panels. Okay, so this is a little hot water service I'm going to be using for our experiment. It's a 50 litre, it's quite a small service, and it's installed with a 1.8 kilowatt heating element. So normally it would just go into a 10 amp outlet, and there's a thermostatic switch inside there. We'll just pull the cover off if we can. So we'll whip the inspection cover off. This is where all the electrical gubbins is. The screws are a bit rusty, but they're coming. Yeah, so in the electrical box, basically this will be the thermostat knob. That probably just comes off there, that's the thermostat. There we go. The power cord comes in. And what we're going to do is we're going to actually take this power cord out and run wires straight to the solar panels. We'll probably put an isolation switch in it so we can disconnect it. Now this morning I went into Bunnings warehouse. I needed some fittings. So what we got down on this is the bottom, is the inlet. So there's a 3/4 to 3/4 BSP fitting, the 3/4 tap, another 3/4 3/4 fitting, and that's just a hose fitting, so I can just feed it with the hose pipe. And up the top for the outlet, there's a 1/2 inch BSP gate valve, and that's a 3/4 to 1/2 inch male. So I can basically shut those off. This tank is pressurized at the moment. We'll run a power cable from the panels to the hot water service, and we'll give it a go. Okay, this is about just after 8:30 in the morning. About 1.5 amps. Temperature is about 35 degrees, and the voltage we've got is get that in there. Voltage 3.5. Okay, the conclusion. Well, my conclusion is it does work to a point. It managed to heat the water in the tank from 35.1 at 8:30, and it was up to 45 degrees when I took the last measurement at 2 o'clock in the afternoon. The problem, the biggest problem was I put the panels on the east facing roof of the house, and on the west side of the house there's a lot of tree foliage, so from about 12:30 the power going into the tank wasn't anywhere near enough. What I'm going to do is I'm going to repeat the experiment because I think it's worth pursuing, and I'm going to use the north facing roof of the shed, which will get the full day of sunlight. And the other thing was the weather was quite cloudy, so it wouldn't have been, the power production would have been on and off all day. So if we get a nice clear day, full sun all day, then I think it'll do the 40 degrees. But that remains to be seen. We'll try that out, and I'll probably make another video. Anyway, that's it for this one, and possibly see you in the next one. Cheers.